Hello everyone and welcome back. In this lesson, we are going to take a look at security rules and encrypting our database inside of Firestore. Some of you might have noticed that earlier in the course, we copied that configuration object from Firebase that we used inside of our Firebase utils, and that code contained an API key. We pushed our code to GitHub, and perhaps in your mind you felt like something was wrong. Typically with any other API key that you've probably ever used before or will ever use requires you to hide it away as a secret because you don't want to expose it publicly for other people to gain access with and then start messing with your services that the API key uses to rely on. This is technically correct for all of those cases, but with Firebase, it's not the case because Firebase's security is handled differently from the API key being put somewhere secret. The reason for this is because Firebase has a very specific way that it wants you to encrypt your data. And we do that using Firebase's security rules. The security rules is almost a language in itself, and it has its own nuances that you kind of have to get used to, but it's relatively pretty easy to pick up once you start using it. And hopefully with these lessons, what I'm trying to show you is how you can set up your rules without getting too in-depth. But you can definitely get really granular if you want, and you can go through the link that I provide you with all of the documentation regarding the actual things you can do with the security rules. In the case of this chapter, we're just going to take a look at how to encrypt our data so we protect it in a reasonable way, but also build a quick feature around these security rules so we see how we can tie React and our current existing application and all the things that we've learned to these new Firebase security rules that we're going to learn. Now, the way that you actually access these security rules is by going to the database tab inside of your Firebase console and then going to the rules tab. Inside of this rules tab, you will see that this thing is broken into two parts. On the right-hand side is where the actual language of these security rules live, and we're just going to ignore that for now. And on the left-hand side, you'll probably only see one date that points to when you probably first instantiated your Firebase console. I have multiple, and all this thing tracks is when you've updated your rules last. In my case, I've played around with it and updated a couple times because, of course, my database is live for a lot of students to use. So different students might accidentally write something to a database and ruin the experience for other students. So I have to encrypt my data more securely than yours, where right now you are just developing against it and you're probably the only person that's using it. In this case, regardless moving forward, this is a great thing to learn about when using Firebase, because the security rules is the primary way that gives you a lot of flexibility and power and control over your Firebase database. So in yours, if we focus on this right side now, you might actually see that yours says allow read and write, whereas mine only says allow read. So before we actually dive into what that means, let's first go line by line to understand what's happening here. Because Firebase's language is kind of particular, so we have to learn about what the language is doing. In this case, this first line here, service cloud.firestore, is mandatory. All this says to Firebase is that the service we're writing these rules for is Firestore, which is the service of our database. Next, this second line, match databases with the database documents, is also a mandatory line because this is going into all of the document objects inside of our entire database. This line represents that we want to write rules for our entire database, and these two lines are both mandatory. Inside of this block here is where we will actually write all of our rules. So the way that the rules work is that they're always comprised of two parts. The first is a match statement, and the match statement points to a route. These routes are going to be built off of what specific routes we have in our database. And they're the routes that you've already used a little bit whenever we were writing new documents or fetching collections inside of our Firebase.utils code. That same pathing structure that we saw and we've already understood about Firebase is the same pathing structure that it wants here, although it's got a little bit more flexibility in terms of what we can do with it. For example, here you'll see that this match statement goes /document and then this 2 stars. This is essentially a wildcard that says that I want to write this match for every single document inside of the database. And the reason for this is because the rules are generally very general when you first set it up. They don't want to impede you, so they give you full allow, write, read, and write permissions. I cannot spell. So what this is saying is that we are allowing anyone to read and write to every single document inside of our database. And this is perfectly fine when you first start developing, but once we put this into production and we actually start shopping our e-commerce platform around, then we would want very specific and granular rules. So there's always a match statement, and then this gets to our second part, there's always an allow statement. The allow statement is exactly as it sounds. It allows for specific things to be done to the documents inside of this route that we've just matched. In our case, there are 2 big general catch-all methods / rules that you can see. Allow read and allow write. Allowing to read represents actually 2 different things. It allows us to be able to get collections as well as get specific documents. If we wanted to be more specific, we could actually break read into both get and list. If we do allow get, then we're saying that we allow anybody to access just specific documents. So they can't actually fetch entire collections, they can fetch specific documents. Allow list is the opposite. It allows people to get the entire list but not get specific documents. So that's pretty much what read breaks down into. Write, on the other hand, is pretty much broken into 2 main things that we're going to focus on. There's a couple more granular things that you can see inside of the documentation that I'm going to link in the resources folder. But in this case, what allow write breaks into is create as well as update. So in this case, create is the ability to make new documents and update is the ability to update documents. That's pretty much all it is. So that's the thing to remember with all of these security rules we're going to write. We're going to make a block that represents a match pointing to one specific collection and the documents inside. And then there are allow statements that we're going to write inside of this block that allow applications to do certain things that we want them to do on that specific collection. So for example, if we want users to only be able to create users inside of our user collection, but we don't want them to update or delete them, then we don't allow for those rules. And we'll explore more of how to actually do that in later lessons. This is more so just a general idea of what the structure of these match blocks and these allow statements are going to be. So in the next lesson, we're actually going to start writing some rules. So let's do that. I'll see you in the next lesson.